Okay, so last time we talked about angles in standard position, right? So it can turn in two different directions. And then the SOHCAHTOA tell us that each ratio has it's the ratio between two sides, right? So we have three combination of the side ratios. So they are called sine, cosine, and tangent, okay? And then we will put the ratios and angles in standard position. So standard position means you need to use the x and y axis. So when the angles are placed on the axis, then it's possible for the ratios to have different sign. Could be positive, could be negative, okay? So from making this sign, the chart here, then we came up with this conclusion, okay? The one I put in red circle, right? So quadrant one is all. All means all positive. Quadrant two says sine, so only sine is positive. So the rest of them will be negative, okay? So, and so on, the same for tangent and cosine. So for example, okay, so I'll be asking, where is sine negative? Then you look at the chart, right? Think about the chart. Okay, sine is positive in 1 and 2, right? Because all positive in 1, right? Sine positive in 2. So that means sine is negative in 3 and 4. Okay, so you use this chart, you can figure out where is sine positive or negative. So another, I can try another one. Okay, for example, I say, where is cosine positive? So you look at the chart again. Cosine is positive in all, right? Cosine is positive in here. So 1 and 4. Okay, so this is what you would answer me. So here I would like you guys to memorize the chart here. The way you can remember is usually at school they will use the first letter of each word and make a phrase, okay? So you can say all and then student, right? Take calculus, right? That's one of them, okay? And then one of my past students, he also made up another interesting one. He said all Smurfs, okay? The Smurf in the cartoon, right? All Smurfs tickle, okay? Cats, okay? So whatever way you can memorize this chart, okay? So I will give you a couple minutes, okay? So memorize this and then I'll ask each one of you a question, okay? So you have to answer me which quadrant, right? So when you are ready, you can raise your hand, okay? But when you are being tested, you cannot look at the chart, okay? Just think in your head, okay? Remember this picture in your head. So raise your hand when you are ready for the little quiz, all right? Any question about the chart so far? Is everyone clear about what to do here? Okay, so one more minute and then we'll begin, okay? Okay, let's try this now, okay? So let's start with any volunteer wants to do it first. Okay, then I'll just pick random. Okay, Angela.
Hello?
Okay. Yeah, let's give it a try. Where is tangent negative?
Uh, oh wait, do I say all three of them?
No, no, you just tell me which quadrant is tangent negative.
Uh, 2,
And
4.
yeah, that's it. Okay, easy, right?
Yeah.
Okay, all right. Okay, let's go on to Annie. Annie?
Yeah.
Yeah, okay. Where is sine positive?
Sine 3 and 4.
3 and 4. Okay, let's look at the chart. Okay, keep your mic on. So you look at this chart, and my question was, do you remember my question?
Sine positive.
Yeah.
Oh, sine positive. 1 and 2.
Yes, 1 and 2. Okay, the chart here is only about positive. Okay, so you think about positive, then the other place will be negative. Okay, let's try one more time. Okay, Annie, how about cosine negative?
2 and 3.
Yeah, 2 and 3. Perfect. Okay, next one, Brandon. Brandon. Okay.
Yes.
Yeah. Where is tangent positive?
Tangent positive. Quadrant 1 and 3.
Perfect. Okay, Chris. Where is sine negative?
Quadrants 3 and 4.
Okay, good. Colin, where is tangent negative?
In 2 and 4.
Yep. Elaine, where is sine negative?
In 3 and 4.
Yep. Okay, Evan.
Yeah.
Okay, where is cosine positive?
4. 1 and 4.
Yep. Okay, Harry, where is tangent positive?
1 and 3.
Yep. Okay, Ivy, where is cosine negative?
2 and 4.
Yep. Okay. 2 and yeah, 2 and 3. Okay, good. Okay, Jenny, where is sine positive?
Quadrant 1 and 2, right?
Yep, that's correct. Okay, Jiawen, where is tangent negative?
3 and 4.
Tangent negative, right?
Oh, sorry, 2 and 4.
2 and 4. Okay, Marcus, where is cosine negative?
2 and 4. 2 and 3.
Yes, very good. Okay, Waylon, where is cosine positive?
1 and 2. I mean,
One.
1 and 4. 1 and
Yeah.
4.
1 and 4. Okay, so looks like everyone understand the chart. Okay, so keep this in mind. Okay, you can either use all student take calculus. Okay, all Smurf cats. Okay, memorize this for checking the sign. Okay, next thing we need to know is the special angle. So please turn to page 5. Special angle means these are the angles, they have special sides. The ratios are fixed, okay? Ratios between the opposite, adjacent, hypotenuse, okay, they are fixed. So one of the easy one to remember is the 45 degree, okay? So you have 45 and 45, right? Two angles are the same. The last one here is 90 degree. When you get this kind of triangle, it looks like a isosceles triangle, right? Because two angles are the same. So the ratios between the two sides here will be 1 to 1. Okay, remember I said here is a ratio, right? So this one is a reduced. So the actual length could be anything, right? It could be double the size. So it could be 2 to 2, right? Because 2 to 2, if I simplify it, it will become 1 to 1, right? It could also be 35 to 35, right? So anyway, they are both the same, right? So that's why we just write a simple one. We just write 1 to 1. Because we are just talking about the ratio, okay? 1 to 1. So if that's 1 and the other one is 1, right? The two sides, you can use the Pythagoras theorem, okay? Pythagoras theorem, does anybody remember what's that? Pythagoras theorem from quite a while ago, grade 8, I think. Has to do with the sides A, B, C. Evan, do you remember Pythagoras theorem?
Was it a squared plus b squared equals c squared?
That's correct, yeah. Okay, a squared plus b squared equals c squared. So now if I place the 1 and 1, right? Because now a is 1, b is 1, right? Then I can put it in to find the missing c side, right? So 1 squared plus 1 squared will be c squared. So 1 squared is 1, right? 1 plus 1 will be 2. 2 is c squared. So how long is c then, Colin? How do we find c?
C is just the square root of 2.
Yeah, square root of 2. Okay, so there we go. We have our ratio between three sides when you get an isosceles triangle. Okay, so you need to remember this one. The triangle is, the sides doesn't have to be these three numbers. Okay, just they are the ratio. So maybe sometimes you might see a triangle that looks like it's still isosceles. Okay, still 45 there. But then the sides could be decimals, right? Or another one that's confusing is when you see root 2. If I multiply every side by root 2, right, this side times root 2, right? Then that will give you root 2, okay? Every side times root 2. And then also the hypotenuse side times root 2. So root 2 times square root 2 will give you 2, okay? So you could either memorize this one, the big one here, or you remember this one, right? So even though the numbers are different, but they are still keeping the same angle, right? It's still isosceles, so it still work, okay? So I think 95% of the time we'll be using the 1, 1, root 2, all right? So just keep that in mind. Next one is the 30, 60, and 90 degree. So whenever you see angle that has 30 or 60, it also has a fixed ratio, okay? So to figure out the ratio for this one, let's put in the angle first. Here's 30 degree, okay? This is 90, so leftover will be 60. Okay, so to figure out the sides, we are going to add another triangle underneath. It's like a reflection of the triangle above, okay? Flip down, okay? Reflection. So that means this angle is also 30, right? This will also be 60, right? It's a reflection of the top one. So now if you look at the big triangle, okay, the red one, after adding the bottom half, the red one, what kind of triangle is it now? Ivy, what kind of triangle do you see now?
Right triangle.
Right triangle, this one, the red one.
Oh,
What kind of triangle is?
I forgot.
Okay, what do you see in the angles? How big are the angles? For the red triangle, right? How big are the angles? What's the degree? What's the value?
acute.
Yeah, what's the number?
60.
60 degree, right? How,
Mm.
so all the three angles are 60 degree for this red one, right?
Mm.
Okay, so when you have three angles that are all the same, do you remember a name for this kind of triangle when three angles are all the same?
Equilateral.
Yes, very good. Okay, thank you. So equilateral triangle. So equilateral triangle, you have three angles the same. Not only that, the three sides are all the same. So for example, if I put 5, then this will be 5, that will be 5 as well, right? I can put anything there. So that's like a ratio as well, right? It's fixed. So now I'm going to choose, instead of 5, I would choose 2. Okay, so every side is 2. And then we know that because the bottom half is the same as the top half, right? So if I erase the red one now, okay, let me erase the red. Yeah. Okay, so this slanted side, the hypotenuse one, is 2, right? Now the one over here, the green side, because it's half of the red triangle before, so the green part will be 1. Any question? Right, because we chose each side of the red triangle to be 2. Okay, that's why it will be 1. If I chose the red one is 20, right? Then the green one will be 10, right? Because it's half of it. Okay, so we just choose a simple number, so then you don't get any decimal or something big. Okay, so we have 20, no, not 20, 2 here, and then 1 here. And once again, I would like to find the missing side down here. Okay, so can you guys try using the Pythagoras again? Okay, we have Pythagoras, a squared plus b squared equals c squared. This one is the c. Okay, this one is the b. We want to find the a. Okay, so everyone please plug into the Pythagoras theorem. Help me find a. When you found it, please raise your hand. Only 4 people found it. Anyone have trouble finding using the Pythagoras? You can keep your answer in square root, okay? You don't need a calculator. Okay, so can I have Elaine? What do you have for A?
√3.
Yeah, what's your answer for the missing side?
√3.
√3, okay, yeah, very good. Okay, √3 is correct. Anyone have trouble getting √3? Okay, so these are the 3 numbers you need to remember now, okay? √3, I'll erase the ABC, okay? Keep the picture simple. So √3, 1, and 2. Square root 3, 1, and 2, okay? Square root 3 is about 1 point something, right? So it's longer than 1. So you can see from the picture, √3 is longer, right? You can write longer. Compared to 1, 1 is shorter. Okay, so why do I bother saying that, right? Why do I care who's longer, who's shorter? Because the 2 is easy to remember. Okay, 2, no trouble place it, right? 2 is always the slanted one. But then a lot of mistake happens when you swap these two sides, right? You might put a 1 at the wrong place, okay? Then that will affect your answer. So the way you can remember it is to think about the bigger angle, right? It's like when you open the door, right? When you open, if you open wider, then the opposite side will be longer, right? If you open narrow, right, then the opposite side will be shorter, right? Short, right? Long. Okay, so same with this one. If I have 30-degree, then its opposite will be the shorter one. If you have this the 60-degree, right, then its opposite will be the longer one. Okay, use this way to remember. Or if you have no trouble mixing up, right, you just remember whatever way you can. But the way I do it is to remember smaller angle will be across to the smaller side, okay? Smaller angle, smaller side. Bigger angle, bigger side. Okay, so that way you don't mix up the location of the two sides. All right. So these are the two triangles. So for example, let's say we want to find sine of 60. Okay, so sine of 60, you need to look at the first picture, right? Sine is which side over which side? Brendan?
Could you repeat that?
Sine is which side over which side? Is it
Opposite over hypotenuse.
yeah, opposite over hypotenuse. Okay, opposite over hypotenuse. Now, if you look at the first picture, looking from 60-degree, opposite over hypotenuse. So what over what then? Marcus?
So it would be for the first one.
Yeah, look at the first one because first one has a 60-degree, right? So opposite over hypotenuse. One number over one number.
Wouldn't it be square root 3 over 2?
Yeah, perfect. Okay. So if you look from 30-degree, it will be different. Okay. If it's from 30-degree, it will be 1 over 2. But the question is 60-degree. Okay. So you use root 3 over 2. Now, if you see an angle that's 45-degree, then you look at the second picture, right? 40-degree is the isosceles. And we're doing tangent this time. All right. So what's the answer for tangent 45? Waylon, can you try this one?
Let me calculate that.
What's that?
I need to calculate that real quick.
Sorry, I cannot hear you.
Can you let me calculate that?
Okay, okay. Let me know when you found it. Look at the second picture, tangent 45.
I got 1.
1, yeah, okay. Opposite is 1, adjacent is 1, opposite over adjacent, so 1. Okay, so this pretty easy, right? If you just have a triangle, right, and you know the angle, then you just fill out the side ratios. Okay, so now we are going to combine the special triangle here and also combine with the old Smurf tickle cats, this rule together, okay? So instead of just writing out the ratio, okay, we also have to think about the location of the angle because that might change the positive or negative, okay, of your answer. So this part, the answer that you got here, these are called exact values. Okay, same with this. These are exact values. All right, so we are looking for exact value in this section. And then they will give you the angles. These are angles. Okay, because they're both numbers, sometimes you get mixed up. Okay, so because they give you the angles, your first step is to draw it out. Okay, so let's write this down. Okay, so left side it says find exact value. Sometimes they will say please find trig ratio. It's the same meaning. Okay, or you can say side ratio. Okay, they all mean the same thing. So first step, because they give you the angle, right? So first step is to draw angle. So we'll try a question together, okay? And then walk through it. So let's say we do question C, and then we'll walk through the steps. So step 1 is to draw the 120 degree, right? Step 1 is draw the angle. So make sure you draw 120 degree in standard position, all right? So you can raise your hand after you finish drawing 120 degree. Anyone has questions about how to draw 120 degree? Because of the standard position, so everyone's picture should be the same, okay? So I'll ask one of you to draw on the screen 120 degree. Please raise your hand when you finish. Marcus, Jenny, Ivy, Harry, any question how to draw? Any? Do you know how to draw 120 degree?
You draw it in the second quadrant.
Second quadrant, yeah, very good, okay. So 120 degree, right, turns to there. Okay, so this is 120 degree. So your initial arm is always on the right side of the x-axis. Okay, so you turn because it's a positive angle, so you have to turn in the counterclock, right? Counterclock rotation. Some of the question below, right, you'll have negative, right? You see like question D will have negative, then you have to turn the other way, right? So your step 1 is to draw the angle. Step 2, right? Once you get an angle on the picture, right, on the standard form, you have to find the reference angle. Okay, what you learned last week? You have to figure out what's the reference angle there. Reference angle, we use this symbol, theta with a little r. Okay? So how big is the reference angle? Okay, if you forgot the reference angle, you can go back and look at this one. Okay, this one is page 2. Okay, reference angle is all the green dots. Okay, depending on which quadrant it is in. Okay, the green dots are the reference angle. Okay, so we're collecting all the knowledge you learned before. Okay, putting it together. All right, so please raise your hand again once you got the reference angle for this picture. 120°, the reference angle. Taking too long, okay? It shouldn't take this long. Reference angle is very easy. Yep, okay. All right, so can I have Jiawen, what's your reference angle?
60 degrees.
60°, very good, okay? Reference angle is right here, okay? A lot of mistake is you use the one with the y-axis, then that will be wrong, okay? So it has to be with the x-axis, right? So that green dot is 60°. Okay, let me write it underneath. Is 60, okay? Theta r means reference angle. Okay, so that's step 2. Now, because we know it's a 60°, right? Then we can think about our special angle at the top. And then fill in the sides, okay? Side ratio. All right, so you look at the picture, you have 60°. 60° is the big angle. Big angle, its opposite should be the bigger and longer side. So once you have that, right, 60° is the bigger angle. So its opposite should be √3. Okay, once you figure that out, everything else falls in place, right? 1 and 2. Any question so far? You look at the reference angle and then you fill out the side ratios. Okay, and then the ratio we are looking for is tangent, right? Question says we want a tangent ratio. So you look at the picture now. Tangent is opposite, right? TOA, opposite over adjacent. So from this picture, what is tangent? Angela?
√3 over 1.
Yes, very good. Okay, opposite is √3. 1 is adjacent, so √3 over 1, opposite over adjacent. So just write that down, √3 over 1, right? √3 over 1. So now you finish side ratio, right? Now you still have step 4, final step, okay? Last step is to check the sign. Check sign means you want to make sure it's positive or negative, right? So this is the time you look at this chart or you have memorized in your head, right? So the angles is in second quadrant. And in second quadrant, is tangent positive or negative? Colin?
It's positive. It's negative.
It's negative for tangent, right? Okay, so you are adding a negative sign. Okay, so negative √3 over 1, which is negative square root of 3. So that will be your final answer. Okay, so this is saying the tangent of 120° will equal to negative √3. So check sign means you look at all Smurf, tickle, cats. All students take calculus. All right, any question? Can you raise your hand if you understand everything up to now? How to carry out the 4 steps?
Can you keep it there for like 2 seconds? I want to copy everything down.
Yeah, of course. Okay, raise your hand if you understand everything so far. If it's any step not clear, let me know now, okay? And I'll try to explain. Okay, Elaine, Ivy, Jenny, any questions? Yeah, okay, everyone's clear, okay? Should we try one more? Let's do one more together, okay? And then you guys can finish the other one, all right? So you guys can pick, okay? Anyone wants to pick a hard one. Anything that appears hard, let's work through together. Anyone? Any question you want to go over? Waylon, how about you pick one?
E.
Which one?
E.
E? So
Yeah.
tangent 150?
Yeah.
Oh, we've already done tangent. Let's try something different.
F. I mean I.
I?
Yeah.
Oh, last one?
Yeah.
Okay, sure. Okay, that one has a negative angle. That's a good choice. Okay, so we just follow the 4 steps. All right, so I'll let you guys draw the angle first. That one is quite a big angle, right? So you have to figure out how many turns it makes. All right, and then make sure you turn in the correct direction. So you guys try it. Okay, draw the angle out. Draw angle. So raise your hand when you finish drawing. So question I. Let's do this one. Step 1, draw angle. Each turn, right? Each complete turn is 360 degrees. Okay, find out how many turns it need to make, and then figure out which quadrant it stops in. If it makes one full turn, right? Negative is clockwise, right? So one full turn will be only negative 360. So you have to keep going, okay? Keep going. Please raise your hand when you got a picture. Okay. Right, can I know how many full turns it makes? How many full circles? Chris, how many full turns?
There's 3 full turns.
Okay, 3 full turns. Okay, so that's one turn, right? So 360, and then 720, right? That's 2 turns. 720, add another 360. So that will be what? 1080, right? 1080. But we're not there yet, right? So far, we got negative 1080. How much more to get to there? Ivy, how much more?
135.
135, okay. So that means it will stop in which quadrant then?
Quadrant 3.
Yeah, quadrant 3, okay. 135 more. I'm gonna use the green, okay, for the extra part. 135. Okay, so that will be the terminal arm. That's where it stops. Okay, so that's your first step. Step 2 is, what is step 2, Harry?
Reference angle,
Okay, can you tell us the reference angle?
45.
45, thank you, very good. Okay, anyone has question about how to get the 45? Reference angle is this dot, okay? And then the green one outside is 135, so leftover 45, okay? The green dot is 45 degree. Okay, 45 degree is a special angle, right? So step 3, what is step 3? Any? Any?
To use sine, tangent, or cosine.
Yeah, we are doing sine here, right?
Yeah.
Yeah, so step 3 is what? What's step 3 called? Did you write down the notes? Step 3?
Oh, I screenshotted it.
Oh, screenshot. Okay, you gotta write it in right away. Okay, screenshot
Okay.
is hard to find, right? What is step 3?
Side ratio.
Side ratio. Okay, let me know if you need more time to write things down. Okay, it's okay. And just tell me.
Okay.
Yeah. So side ratio, we want to put in the sides. So what are the number that we should put in? What are the sides? "45 degrees. What are the 3 sides? You know?
No.
Okay, then you look at the triangle we had above. Do you see the 45-degree triangle?
Yeah.
Okay, so what are the 3 sides?
1, and square root 2.
Yes, okay, so that's where you get the 3 sides, okay? So you put that into your picture. So 1, square root 2. Okay, step 1, draw the angle. Step 2, get the reference. Step 3, you look at the triangle, fill in the sides, side ratio. Got it so far?
Yeah.
Yeah, okay, can you continue and tell me, we want sine, right? This question is sine. Sine is what over what?
1 over square root 2.
Okay, so you fill that out, 1 over root 2. Okay, and then step 4. I have Jenny, what is step 4?
Step 4 is check the sign.
Okay, so will this one be positive or negative?
It would be negative
Because
the question was negative.
okay, not because of the angle is negative, okay? How do you know it's negative there?
Because it's going clockwise.
Not because of that.
Oh.
You have to think about the quadrant of the angle. Which quadrant is the angle in?
Oh, so it would be positive, right?
Don't answer the question yet, okay? Can you tell me which
Okay.
quadrant is this angle inside? 1, 2, 3, 4. Which one is it in?
3.
Yeah, it stops in quadrant 3. Okay, so can you tell me which one is positive in quadrant 3?
None of them?
Hmm?
I mean,
My
like,
question?
wait.
You have to look at this chart. All
Oh.
symmetrical cats, right? That's for checking positive, negative. So quadrant 3, who's positive there?
Is it tangent?
Tangent positive. Who's negative there?
I'm not sure.
Everything else.
Okay.
Who's everything else? Other than tangent, what do we have?
Sin and cos.
Sine and cos. Okay, sine, not sin. Sin is bad. Okay, so
Okay.
sine and cosine. Okay, so sine and cosine will be negative there. Tangent will be positive there. Okay, so look at the question again. Right, so we are in quadrant 3.
Mhm.
The answer be positive.
Sorry, you cut out.
The answer be positive or negative now.
It would be negative because sine is negative there.
Yeah, sine is negative in quadrant 3. Okay, so you need to get the right reason for negative. So angle, it doesn't matter angle is positive or negative. It doesn't affect your sign. It's whether you are doing sine, cosine, or tangent, and also depends on which quadrant your angle is in. Okay, then you use the all student take calculus to check it out. Okay, to find out the sign. Any questions about this one? Okay. Can you raise your hand if you understand this question as well? Okay, Waylon, do you have any questions?
Oh, no.
Okay, so this. When you are doing homework, okay, you need to show the work. All right, because if you just punch into the calculator, it doesn't show me anything like whether you understand or not. And sometimes when you type into calculator, it just come up with a decimal answer. Then that is not exact value, right? So in the homework, when you are doing it, you need to show the picture, right? First, you need to show the drawing the angle, and then you got to show me the reference angle, right? And then finally, you have to tell me the answer, right, for the ratio. Okay, so you can highlight that, right? So 1, 2, 3. Okay, these are the 3 things you have to show on the homework to get a full mark. Okay, let's do one more, okay, before you guys go for a break. So pick another one. Jiawen, how about you pick one more? Jiawen, which one do you want to do?
D.
D, okay, cosine, sure. Okay, let's do, so now we have example for sine, cosine, and tangent then, okay? Good pick. All right, so everyone please draw this out, okay? This time I'll let you try mostly by yourself. So maybe you can get to the final answer by yourself. So just raise your hand when you have finished, either finish or whether you get stuck or finish, you can raise your hand, okay? And then we'll go over. Remember this question, that angle is turning in the negative direction, okay? Whether you're sure or not about your answer, it's okay, okay? Just try it out and raise your hand when you finish. Okay. Any, Harry, Jenny, Marcus, do you have any questions? Okay, Waylon, do you have an answer for question D? What's your final answer, Waylon? Okay. Yeah. Can you say out your answer? You say you're lagging. You cannot hear me or what? Waylon, can you turn on your mic?
Okay.
Yeah. What's your answer?
I think it's 2 over square 2.
What? What did you say?
2 over square 2.
2 over square root 2. Is that right? Is that what you said? Waylon?
Yeah.
Yeah. Okay. Anyone else? Anyone got different? Marcus, how about you? Marcus?
I'm still working on it. How do you find the like for instance on C where it's on the triangle? How do you find the opposite and hypotenuse? And yeah, like the sides.
The three sides? Okay, first you have to figure out the reference angle. Do you know why it's 60 degree?
Yeah, I know how to find the reference angle.
You know, right?
Yeah.
Okay, so once you figure out the reference angle, then you look at the picture. The two triangles, the special triangles.
Okay.
Okay, so you look at 60 degree, right? The one I'm using the yellow highlighter. Do you see now 60 degree?
Yeah.
So across from it, what's the number across from the 60 degree?
Square root 3.
Yeah, so that side is called the opposite.
Okay.
So the root 3 is always across to the 60 degree, okay? The opposite is always root 3 for 60. And then once
Okay.
you figure that one out, then the other side must be 1, and the hypotenuse is always 2, okay? For the angle, whenever you see 30, 60 degree, it's always this triangle, okay?
Okay.
Right. Let's go back to here, question D. Do we have any different answers? Everyone got the same? Yeah, Elaine? What do you have?
1 over root 2.
1 over root 2. Okay, let me write that down first. And Colin, how about you? You say something?
1 over root 2.
1 over root 2. Okay. How about Braden?
1 over root 2.
Over root 2. Okay, let's go over, go over the steps. 315 negative, okay? So you have to turn clockwise, right? It will be stop in quadrant 1, right? Negative 315 will be there. And then you make the reference angle. Reference angle will be here. If the red one is 315, then reference angle must be 45. And we don't care if it's positive or negative, okay? Do not put negative 45 degree for reference. Reference is just the size, okay? Size of the angle. Okay, once you get that, right? 45 degree is the one with isosceles. So 1 root 2. Right? And then we want cosine, right? Cosine is adjacent. This is adjacent over hypotenuse. So 1 over root 2. Finally, you need to check the sign, right? This one is in quadrant 1. Quadrant 1, all positive, right? Everyone is positive. So this one is positive. Okay? If you have questions, you can stay during the break. Okay, ask me. Otherwise, we'll have a break for 10 minutes. Okay, so I'll see you guys at 2:50. Okay, 2:50.